So everybody, let's go to Mark next. Mark Sokol, who is hiding. There we go.
Hello, everyone, and give you a short update. I don't know how much stuff I actually have to show, but I know Jeremiah was doing a couple experiments over the past few weeks, and there was some stuff coming out from Wayne as well. But here in the lab, the most exciting thing that has happened is the 3D printer has arrived, and we started printing out some stuff. We started out by, I got this material called ASA, which is a very strong dielectric. It's this white plastic material over here. The first print that we got on it was, it sort of warped. I had to raise the bed temperature. What we're using the plastic for is going to be inside the waveguide chamber where we're going to test the Alzaphon experiment. This is going to act as a support or sort of a skeleton for the copper chamber. This way, if the chamber is out of tune, I can merely change the size of the plastic and, change the dimensional size of the chamber. Because it's a strong dielectric, the microwaves will pass right through it. It'll essentially be invisible to microwaves. There was a couple iterations of the outer ring. I had to print it a little tight in order to make sure that it was a tight fit. Turned out it was too tight. I wasn't able to get it on over here. So I'm trying to stick it on over here. I even put a little lip at the edge of it. And right now we are printing out another design for the outer lip. I'll show that to you with the printer. So this is a section of the lab that we cleared off in order to make room for the 3D printer. So here is the computer, basically using SketchUp to model out these designs. In this design over here, it's basically going to be the same ring design, and we're gonna have these plastic wedges over here that you can stick in for different sizes. So as you make it smaller, you're able to stick the wedges in deeper and get a nice tight fit around it. Here's the controls for the printer. Here's the printer itself. It says we have about a half an hour left for that print. See the wedges are kind of done already, and it's just doing the large outer ring. Also, we got lots of different types of plastic: PLA, TPU, ABS, PETG. There's also conductive materials and magnetic materials that we're getting. The conductive arrived already. Magnetic's on its way. That will allow us to print some really cool experiments. There is also a material that has tiny microscopic beads of copper embedded in it. It's non-conductive, so it's basically the Banduric, the dot product disk experiment right there. All you got to do is print it out on the printer, and you got yourself a dot product disk for that experiment. Also, this is kind of cool. Polycast. This is a 3D printing material that you can print out, and then you cast it with sand around it and stick that in an oven to warm it up, and the plastic just disappears. It turns into fumes and stuff. So that will make you a perfect casting mold. And here's some spare parts. So that's pretty much what's been happening here in the lab. We had some trouble setting it up, and we were in contact with the manufacturer, and that is what's going on.
Awesome. Well, that's actually, I like the way you have the monitors. That's the part that got me. When you walk in, you have the monitors angled towards you. That's cool. That's cool.
Standing desk.
So now, in terms of the 3D printer, I mean, I know that you've got a few projects going on, but is that the kind of thing where you could substitute? I mean, you could probably print pretty much anything out with it, right?
There's a lot of experiments that we could print right now that we have a 3D printer of this size. This is actually my 4th 3D printer, and all the previous ones died from overuse, just from failure over the years. I've had 3D printers going back to the Solid Doodle 1, which was back in like 2013. So yeah, and those were the kind of printers that kept on breaking, changing parts and all that stuff.
Well, and you can print stuff in too. The reason I'm asking is stuff like Hector Serrano's gravity capacitor, or I'm thinking of his older designs, but you could print a sealed enclosure with conductors inside of it too, right? So
Yes, yeah, you can. With this conductive PLA material, we can actually print like circuit board kind of setups. It does have pretty high resistance. It's a couple like 10 ohms or something like that per centimeter. So we're not talking about level of copper or even aluminum. It's pretty down there in how conductive the material is. But yeah, it's pretty amazing that we're able to have all these capabilities: a strong dielectric and uh, an okay conductor. Also, we have materials with magnetic properties. They have bits of iron in them. That material is actually pretty interesting. It has enough iron in it to actually oxidize. So if you don't cover it with something, it'll rust.
Hmm. Interesting.
Yeah, which is pretty cool.
Yeah, no, that is well, awesome. Well, thank you for sharing that.